Alright, so we're going to pull our spring back to 0.1 meters away. Spring constant 200, mass 4 kilograms. We're going to go ahead and let go. We want to know the maximum velocity. So first of all, where does the max velocity occur? At the equilibrium point. So right here at x equals 0, that's going to be our maximum velocity, right? So what kind of energy do we have way over here? Okay, you can call that US max. What kind of energy is it right here? You can call this KE max. Okay. What is the KE right here on the end? 0. What's the US right here? 0. So anyways, for letter D, we're going to do E initial equals E final. Initial energy is going to be US max. And E final is going to be KE max. Okay, 1/2 kx squared. 1/2 mv squared. Okay, solve for v. So this should be kx squared over m square root. Substitute in the numbers, and what do we get? Okay, so it looked like 90% of you got that one. We're good. Okay, now letter E looks like it gave some of us some problems, so let's make sure we can do E in detail. So again, we're going to go E initial equals E final. So what should we use for our E initial? Okay, it doesn't matter what you want to use. You could either use US max, or you could use KE max, because you now know the KE max, right? The thing you know is that's all the energy is in the US max or the KE max. Now when we look at the halfway point, we're looking right here at 5 centimeters. So this is our x equals 0.05. So what kind of energy does it have at the halfway point? Kinetic and potential, right? It has both of those right here. So it has both kinetic, we'll call it KE5 plus potential, US5. Now if you were just to blindly guess the velocity, what might you guess? Half, okay? So, you should always go in with maybe a guess, half, okay? Unfortunately, in this case, you would be wrong. So let's see what happens. So let's find US at 5 plus KE at 5. So our US max is 1/2 kx squared. That's at the max. This should equal 1/2 kx squared. This is at 5 plus 1/2 mv squared. This is also at 5. Okay, so do some algebra. Subtract that, right? So you're going to get kx squared max minus kx squared at 5 divided by m. That should equal v squared. So if this were like a variable only problem, you were solving for v, it would be the square root of that, right? And then go ahead and plug in the numbers. And notice that you don't get half. What do you get?
6.
Okay. And how did it compare? To half. Okay, it's more than half, right? Why is it more than half? And the acceleration also, I mean, it has a smaller velocity. It's like here, like when you drop something, okay, when you're halfway, it's not going to be double the velocity or half the velocity than when it's all the way, right? It's not as simple as that.